So for those of us on YouTube, this is 7-3, similar triangle. So last class we learned about similar polygons, and today we're going more specific to similar triangles. So let's remind ourselves what it means to be similar. Similar shapes have all of their corresponding angles are congruent. And in addition to that, all of their sides, all of their corresponding sides are proportional. I'll zoom out in 1 second. Let me just write this semi nicely. Okay. All angles are congruent and all sides are proportional. So we have to remember those two things when we do similar triangles. When we learned about congruent triangles, there were like 5 shortcuts I gave you. I said, okay, there are these 5 theorems, and if we use them, then we're able to easily tell if a shape is, if a triangle is congruent to its other triangle. And there were 5 of these. Let's list them. Triangles, congruent theorems. 1, 2, 3, 4, 5. And they were just 2 or 3 letters. Does anyone remember one of these? What's one of the ways we proved these to be congruent?
Angle, side, angle.
Angle, side, angle. Very good, Donna. Angle, side, angle congruence. That was one. What's another one?
SSS.
SSS. Very good, Nolan. Another one?
Side, angle, side.
Side, angle, side. Good, Kamara. We got 2 more.
HL.
HL. And then 1 more with 3 letters. Anyone remember that?
Angle, angle, side.
Angle, angle, side. Very good, JJ. Angle, angle, side. So these were things that we knew really well back in, what was that, unit 4, I think? I don't remember exactly which chapter that was, but we knew those all really, really well a couple chapters ago. This time, I'm not going to make you know 5 of them. I'm only going to make you do 3 of them. Now, these were the 5 that worked, but there were a couple that didn't work. So remember, like ASS did not work. Also, SSA did not work. And the last one that didn't work, AAA, that was not enough information to prove that they were congruent, but this is actually one way that we're going to prove that they are similar. So those were 3 ways that didn't work, but AAA similarity is the first way that I can tell that 2 triangles are similar. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then we know that they're similar. What comes from that is the third angle theorem. So remember, if 2 angles are congruent to 2 angles here, then those third angles have to be congruent because all of these, sum of the angles is 180, and there's only one other number that makes that happen. So this is technically AAA, but we only need 2 of them. We can just assume the third one's congruent. So if we see 2 angles are congruent in each triangle, that is enough information to say that they are similar. Another one, the other 2 actually are ones that we've already done before, SSS and SAS. So SSS, if the measure of the corresponding side lengths of 2 triangles are proportional, then we have similar triangles. So that means all of them have the same ratio, like 1/2, 1/2, 1/2. Similarly, SAS is the measure of 2 side lengths of one triangle are proportional to the 2 measures of 2 other corresponding side lengths of the other triangle, and their included angle is congruent. So it's like if we have 2 sides that are proportional to the 2 sides over here, and then this angle is congruent, then we know that by side, angle, side, these triangles are similar. All right, we're gonna do a couple examples. This first one, determine whether triangles are similar. Okay, I got nothing on angles. That's not gonna help me. No idea what's happening with angles. What I do know is my sides. So I'm gonna start making some proportions. When I only have sides and I'm not really sure what goes with what, I always put the 2 smallest ones together, I put the 2 biggest ones together, and I put the medium together. So these 2 are the smallest ones. So I'm going to do 6/9. And I'm going to simplify that. So 6/9 becomes 2/3. I'm going to do the biggest one next because I think those are easy to identify. So I'm going to do 10 over 15. Well, 10 and 15 have a common factor of 5. That becomes 2 over 3. Okay, just because we've got 2 that works does not mean we're done. We have to check the third one. So the third side is 8 over 12. 8 over 12 divide by 4, I get 2 over 3. Oh, nice. I don't know anything about the angles, but that doesn't matter. I have here side, side, side similarity because all 3 of the sides are proportional to each other. They have the same scale factor as 2 over 3. So I'm going to write yes. And I'm going to say by side, side, side similarity. Remember the other day we learned the similar sign is like the tilde. It's like a congruent sign without the equal sign. So that was it. I just did all my scale factors. They're all the same. I'm going to say yes, we're good to go. Any questions here? All right, let's look at the next one. This one says determine whether the triangles are similar. Okay, I don't have 3 sides here, but I do have that these 2 angles are congruent. That's helpful. So my angles, one of my angles is congruent. So now I need to see if my corresponding sides are proportional. So again, I'm going to do the smallest ones together and then the biggest ones together. So I've got 3 and 4. Those are the smallest ones. So I'm going to write 3 over 4. Ooh, and I can't simplify that anymore. That's as good as it gets. Okay, that's fine. Let's go to the next one. I've got 6 and 8. 6 divided by 8. 6 and 8 have a common factor of 2, so I get 3 over 4. Oh, nice, that works. 3 over 4, 3 over 4, and I have the included angle. I'm going to say yes, they are similar. By which similarity are they similar? Is it AA, SAS, or SSS? Which theorem?
SAS.
SAS, very good, Nolan. SAS similarity. That's all those first 2 questions asked. We just had to check their ratios and see if they were similar or not. We're gonna do the same idea for the next few. I'm gonna do one more together and then I want you to try a couple. So we're gonna jump and do this one that has actually nothing labeled on it. And I think that's plenty of information to tell if these triangles are similar or not. The other 3 look like the first 2 we did, so I'm gonna have you try those on your own. Okay, right here, I've got one triangle on top of another triangle. I've got triangle LTS. And it's on top of RUT. I know I didn't name those in order. That's okay. I just wanted to kind of separate them. Let's separate them and look at them separately and see if that helps me figure out if they're congruent or if they're similar or not. I have no side lengths and I can't just like make up a side length if there's nothing given to me. If there's no variables, if there's not even a little bit something to work with, I can't just make up any side lengths. So our only hope here is our angles. Now I see that they both have the angle T. Here has T, here has T. That means that they both share this angle right here. So no matter what T is, it's congruent in all the shapes. Congruent, congruent, congruent. Okay, that was pretty easy. The next part is recognizing that we have this really helpful hint right here of parallel lines. They're not congruent, but they are parallel. And when we have parallel lines, I want us to remember back in Unit 3 where we learned about parallel lines and the relationships between them. I can do a transversal up here at RS, or I can do it down here at UT. It doesn't matter. I'm just going to leave it down here because I just drew that one the most recently. I know that these 2 angles are congruent. This angle and this angle. Does anyone know what the name of the relationship between those 2 angles is? What do we call those? We had a bunch of different names for angles. We had like vertical and linear and alternate interior and corresponding and consecutive interior and alternate exterior and alternate interior. I realize my L and S need to be flipped, so let me flip those. Who remembers what we call those two angles, U and L? Why are they congruent?
Are they corresponding?
They are corresponding. Very good, Kamara. They are corresponding. So when they're like in the same spot of the line, so this is like two, like on top of the transversal and then to the right of the parallel line, they're in the same spot. They're corresponding angles, so they're congruent. By drawing these triangles separately, I can see that it's helpful that these two angles are congruent to each other. And by third angle theorem, we'd assume S and R are congruent to each other. And so this is plenty of information to say, yes, these are similar. I don't have any sides, so this one is by AA similarity. Oh, then it says write a similarity statement. We got to write a similarity statement. Let me give you one. I'm going to say this one is TSL is similar to what? Triangle TSL is similar to which other triangle?
TRU.
TRU, very good, Drew. TRU. Okay. Do you think you can try the next couple on your own? Actually, let's do one more together and then I'll have you try the last two. Let's do one more together. If you got a head start, good for you, but let's do one more together. I see here that I've got this angle and this angle. They're both 90. They're both congruent, easy. Okay, we got one angle down, but now we got to do the sides and see if they're proportional. Which side goes with 36? I'm going to write 36 over what? What's that corresponding side?
24.
24, very good. Thank you, 24. Why is it 24? Why is it not 18? Does anyone know? This is what we struggled with last class. My other period did too. Anybody know why we picked 24 to go with 36? It's okay if you don't. Okay, we did in the last class, and I think I mentioned this a couple times in our homework, but I don't think it's really like connected yet. The big side on one triangle goes with the biggest side in the other triangle. So what's given to me in like the triangle KLJ, 36 is a bigger side than 20. Similarly, in WXY, WX 24 is the bigger side than 18. I don't know why I wrote W small. So I have to do the two large sides together and then I'm gonna do the two small sides together and see how they compare. There's no way for me to do a big side and a small side and it to be the same as another big and small side. So we have to do these two together. All right, let's simplify. 36 and 24, they both have a common factor of 6, I know that. So that becomes 6 and 4. Ooh, I could have gone one more time because now 6 and 4 have a common factor of 2. So I could have done 12 to begin with. That's okay. So divide by 2 and I get 3 over 2. Okay, cool, awesome. Now I need to try the other one. I need to do 20 over 18. I want it to equal 3 over 2. All right, 28, 18 both have a common factor of 2. Okay, so I get 10 over 9. Okay, that's as simple as that gets. Ooh, wait. But is that the same thing as 3 over 2? Is the same scale factor? I hope you guys think that's such a silly question. You're just not even offering me an answer. No.
No.
No, thank you, Drew. No, they're not the same. 3 over 2 and 10 over 9 are not the same, and there's no way for me to make them the same. So we're going to say not proportional, which is what makes them not similar. Oh God, if I could spell proportional, that'd be cool today. Proportional. Okay, not proportional. They are not proportional. They do not have the same ratio, so they are not similar. So I don't have to do anything else. Okay, now I'm going to be quiet for a minute. I want you to try the next two. Take a second, try the next two. Okay, take another minute. Okay, so you should be finishing up those two. We had to again check our our similarity statements before we could do much of anything. I'm gonna need help with that. So think for a second. You can help me. Okay. Whoop. Think for a second. Okay, sorry, I was doing something really quick. All right, who can set up one of my ratios for the first one that we have to do? BFA, BFE, and LM. What's one of the ratios I'm going to have?
I mean 24/16.
Very good. 24/16. Kamar got kicked out and was the first one to answer a question. Good job. 24/16. These look really nice. They like lined up kind of perfectly on what goes with what. So Kamara just knew that the ones on the left went together. So 24 and 16, they have a common factor of 8. I think that becomes 3/2. Angles B and N are congruent, so that's good. And then my last ratio, I feel like this is a gimme. So, I did not mean to do that. 39/26. I know 39 divided by 3 is 13. I think 26 divided by 13 is 2. I can always check if I'm not sure. Yep. So I get 3/2. Oh, awesome. They are the same scale factor. So that means, yes, we have some similar triangles. And this time it's by what? Which of my 3 theorems is this? Are we allowed to say that these are similar?
Side, angle, side.
Side, angle, side. Very good, Nolan. And then last thing I want to do is a similarity statement. So let's say I have triangle EBF. That's similar to what other triangle? I said EBF.
MNL.
MNL. Awesome. Thank you, Nolan. MNL. Okay, cool. That worked. Let's try the next one. We've got a lot going on here, so we got to start setting up some ratios. Somebody I haven't talked to for a minute. Give me a ratio.
32/20.
32/20. Very good, Lydia. 32 is the medium side. 24 and 40 are small and big, so 32 is in between, and 20 is in between 15 and 25. Good. 32 over 20. Those both have a common factor of 4. I think 8 over 5. Okay, awesome. Lydia started us off strong. Who's got another ratio?
24 over 15.
24 over 15. Very good, Abby. 24 over 15. They have a common factor of 3. I couldn't remember last class. Someone had to help me, but I think it's 3. So that's 8 over 5. Okay, I'm sensing a pattern. And then the last ones are left. I'm not going to ask you that because that should be a gimme. 40 over 25. And they have a common factor of 5. So 8 over 5. Oh, nice. It worked out beautifully. All of them have the same scale factor. So I'm going to say these are similar, yes, by which theorem do I get to use this time? Anybody? What theorem do I get to use?
Is this side, side, side?
It is side, side, side. Really, very good. I have no angles. I've got no information on angles, so I'm just going to do side, side, side. All right, and then now I do have to write a congruency, or sorry, a similarity statement. So I'm going to say this is IHG is similar to which triangle? IHG.
SQR, or no, SRQ.
SRQ. Very good. Thank you, Billy. SRQ. All right, anybody have trouble with those few? Any questions? All right, let's keep rolling. The next one says this next set of directions is essentially we're using similar triangles. So we're using the fact these are similar to solve for X and Y. So we know ABC is similar to DEF. If these shapes are similar, then that means angle A and angle D are congruent, angle B and angle E are congruent, and then angle C and angle F are congruent. All of their corresponding sides are proportional. So let's find out what that proportion is. Let's find that scale factor. And there's really only one option here. Who can figure out which sides go together for us to find our scale factor? Who's got me? You can write a ratio.
18 over 9.
18 over 9. Very good, Kate. 18 over 9. There's no other option. There's no other choice because it would be y and 18, which that doesn't simplify, and then 18 root 3 and x, and that won't simplify. But 18 and 9 simplify really nicely to just be 2 over 1. Now, normally we write 2 over 1 as just 2, but this is a ratio. It's a fraction. It's like something to something else. So we're going to keep that 1 on the bottom. We're going to write 2 over 1 equals another ratio to find both x and y. So you can pick whichever one you want. Can somebody write one of my other ratios? So 2 over 1 is equal to what over what? What's my other set of sides I'm going to do? You don't have to solve, you just have to set it up, right? So what's another set of sides that go together?
Y over 18.
Y over 18. Good, Gavin. Y over 18. So I've got y over 18, and that's going to be a really easy problem to solve. 1 times y is just y, and then 2 times 18 is 36. Oh, nice. I don't even have to solve. Y equals 36. Easy. All right, so Gavin helped me find y. Now I got to find x. Can someone tell me what my ratio is that is going to equal 2 to 1? What over what? Again, you don't have to solve it, just which 2 sides go together. Hello? Anyone out there?
Radical 3 over 18.
Oh, there we go, Drew. I got 18 root 3. And then does x go on top or bottom of that? Drew, does it go 18? Ooh, that's not what I want to write. Does it go 18 root 3 over x, or does it go the other way around?
That's right.
Oh, I
For
was
sure.
okay, good. I was right because when we went from 18 to 9, we went from the triangle on the left to the triangle on the right. So if I have 18 root 3 and x, I have to go from 18 root 3 to x. So x goes on the bottom. We all get a little bent out of shape about radicals, but we're going to be using those a little bit more frequently in the next couple units. So let's get a little bit more comfortable with them. 2 times x is 2x, and then 1 times 18 root 3 is just 18 root 3. And it's just algebra. Let's divide by 2. When we're dividing by 2, I can only divide the number outside the radical by 2. I cannot touch the radical. I cannot touch the square root. I have to leave that by itself. 18 divided by 2 is 9 root 3. So that's what that equals. Okay. Any questions so far? Okay, I got another problem on this side, and then we want to do a couple on the back before we're done for today. The next example says a person 6 feet tall casts a 1.5 foot long shadow at the same time that a flagpole casts a 7 foot long shadow. How tall is the flagpole? So I got to set up with a little picture, but we got to like label this picture so we know which pieces go together. It says I've got a 6 foot tall person, so I can think about a person right here. Yeah, little stumpy legs. That's okay. 6 feet tall. And they cast a 1.5 shadow, 1.5 foot shadow. The flagpole casts a 7 foot long shadow, but we don't know how tall it is, so I'm going to put an X there. All right, so I've got height, and I have shadow, and I even made them look like shadows. Okay, there's a couple different ways we could write this proportion. Does someone want to set it up for me? I've got something over something equals something else over something else.
Is it just 6 over x and then 1? I mean, yeah.
We could do
Yeah,
that.
1.5 over 7.
We could do that. That's good, JJ. So we could do that because we're doing 6 and x, which are the heights, and then we'll do the shadows. And you kept the person on top and then the flagpole on the bottom. That works. Did anyone think of a different way of writing their proportion? Another way you could do it is you could do all of the person together and then all of the flag together. So I could do like 6 over 1.5 and then equals x over 7. And you can flip all of these. At the end of the day, I'm going to have to cross multiply. So I'm going to do 1.5 times x and 6 times 7. And if you look at the new proportion I just wrote, it's the same thing, 1.5 times x and then 6 times 7. So we're used to doing it the way that JJ set up for us. So I appreciate that you said that way first. But if you thought it the other way, that's also correct. Technically, it still works. So I'm going to do 1.5 times x, which is 1.5x, and then 6 times 7, which is 42. And then when I divide those two, I believe I get x equals 28. So it's a 28-foot flagpole. Okay, any questions so far? All right, I want to do 2 more problems and we'll do the rest of them in class on Wednesday. I'm going to do these 2 before we leave. All right, so the first one, the directions say identify the similar triangles, then find each measure. So we got to find which shapes are, or how the triangles are similar. So I'm going to zoom in here. We've got a lot going on in this picture. I want to tell by the by the angles that this is congruent, or by these are similar, excuse me, I keep messing that up. The angles at B are vertical angles, so they are congruent to each other. I also need to get used to every time I see these parallel lines, ED and AC. Ooh, that's a bad one. Anytime I see parallel lines, I'm going to try and find a transversal for them to cut. So then I've got some angles that are congruent. This time I don't have corresponding. I've got these angles are congruent. Does anyone remember what these angles, why are E and C congruent? What's the name of those?
Alternate interior.
There we go. Okay, I got a couple of responses on that. Alternate interior. My other class couldn't remember, so good on you guys. Alternate interior. So now I've got two sets of angles congruent. So I'm going to say, yes, we have similar triangles by angle similarity. And then now that we know that we've got similar triangles, we want to figure out what angle X is, or what side X is. So I'm going to set up a proportion. I've got one ratio equals another. Let's start with the sides that we already know. What's the ratio of the two sides that we already know from each shape? What over what?
30 over 60.
Very good, Drew. 30 and 60. So those have to go together. They're corresponding sides, and they're the only sides that we know one from both of the triangles. Now I got to figure out which side goes with X. What number goes with X? X over what? Are we quiet because we're getting lazy, or are we quiet because we don't know?
Is
Is
it
it 38.6?
23?
It's going to be 38.6. I know there's a lot of numbers over there. 23 refers to AB, this side right here. And then 38.6 goes with BE. AB can't work with X because they're in the same triangle. So I can't do like one side from one triangle with another side from another equals two sides from the same triangle. That won't be proportional. But EB, that length is the same. It's the corresponding length to CB. And so I'm going to do X over 38.6. I don't know this side, so I can't do anything with 23. 23 is like a distractor. Or anybody have questions on that? Are we okay with that? Okay, let's cross multiply. I get 60x equals, well, I got rid of it from last class, 30 times 38.6, which is 1,158. And then we divide by 6, and I get 19.3. I'm going to know that that fraction, that decimal is okay, and I'm not going to stress too much about it because I used a decimal to find it. So since my problem already had a decimal, I'm really not too concerned that I get a decimal here. Okay. Any questions on that one? Okay. This last one is another one of those overlapping triangles. So I'm going to separate them into two different shapes. So I'm going to redraw FRQ over here. And from F to R was 30, and from F to Q was 32. So I'm going to bring those numbers down with me. And then I'm going to copy the big shape FNP. A lot of times we just want to see like the little like trapezoid. We want to see like this shape right here. And there's no way for a trapezoid and a triangle to be congruent. Not congruent, similar. Well, that's also true. They're not going to be congruent either. But there's no way for a trapezoid and a triangle to be similar. So I have to think of like the big triangle, not just that little trapezoid that they are overlapping at. So my triangle is FNP. I know NP is 22. I know that Fn goes from here all the way up to n. So Fn is not 10, it's 30 plus 10 or 40. And then Fp is not just x, it's going to be 32 plus x. So I gave us a lot of tools now. We want to find, we want to set up a proportion so we can find x. Who wants to write it for me? What over what equals what over what?
– 40 over 30 equals 32 over 32 plus x. Or I mean 32 plus x over 32.
32 plus x over 32, and then do you say 40 over 30?
Yeah.
Awesome. Yep, that works. I like that you fixed yourself because you knew you put 40 on top and then 30 went underneath that. So that when you did the other sides, you knew that 32 plus x had to go on top and 32 had to go on the bottom. Good job, JJ. Thank you for helping me. Okay, a common mistake that a lot of us want to do is we're like, oh, we've got 32 on top and bottom, let's cross them out. I'm going to tell you right now that you are not allowed to do that because we have a plus sign right here. If it's being multiplied and it's on top and bottom, you can get rid of it all day, but not with a plus sign. I'm sure that's a mistake we'll make as we keep going, but I just wanted to alert you of that as we go along. So 32 over x, or 32 plus x over 32 has to stay that way, and we're going to cross multiply. So I get 30 times 32 plus x over, or equals 40 times 32, and I get 1280. Distribute, so I get 30 times 32 is 960 plus 30x equals 1280 minus your 960 from both sides, so I get 30x. I don't know why I just wrote a k. 30x equals 320. Wait, did I do something wrong? Oh no, I think I did something wrong last class, so that's not what I got last class. All right, 320 divided by 30 is going to be a decimal. You can make it a fraction if you want, but it's about 10.7. That's what my key says, but that is not what I told last class. So that is last class. I hope you watch this. I think we just made a simple algebra mistake last time. Okay, any questions on what we just did? We're gonna do this last one on the right and then this word problem underneath on Wednesday when we see each other in class. But remember, until then, there's a homework for you to work on. So it has some 7.2 on there as well as 7.3. So this homework is due on Wednesday when I see you. And I believe I already put a little assignment block up. I'm gonna stop my share and I'm gonna stop my recording.